People, my name is Emerson Rodrigues, and in this video I would like to talk about how to resolve weak coverage problems, okay, on the LTE networks, okay, whatever equipment, doesn't matter, Huawei, Nokia, Siemens, Ericsson, Alcatel, ZTE, is the same procedure, right? Okay, so you need to first of all analyze the geographical environments and check the received levels of adjacent ENOBs, because it's affect a lot the impact on the network. Okay, I will talk further in the parameters and the behavior networks that can affect each specifically parameters that affect the behavior networks, and other sites and the edge sites, and can disturb your network a lot. Okay, you need to analyze the EIRP of each sector based on parameters configurations and ensure that EIRP can reach maximum values if possible. What I mean, EIRP, equivalent isotropic radiated power, okay? If it's possible, the EIRP. So increase the pilot power, okay? Increase the adjust on the next step. Adjust antenna azimuths and tilts, increase antenna height, and use the high gains antennas. I will talk about specifically about antennas in one video specific for antennas, okay? Just pay attention for that. Which kind of antennas affect the behavior or properly used, for example, to subways, to like a beach area, or for example indoor. We're talking about the phantom cells too. Please pay attention in my next videos, okay? We'll talk about everything, alright? So then you can deploy new ENOBs if the coverage hole problems cannot be resolved by adjusting antennas. We have it properly forecasting tools like for Tioco and other companies like IBWave as well, but cell plant as well. So we have good tools. I worked since 2001 with worked with Tornado. I work with to planning and then the optimization. Tornado, Aricon Asset 3G, and then they changed it, moved it. Okay, but it's okay, that's fine. Just to understand a little bit. Increase coverage by adjacent ENOBs to achieve large coverage overlapping between two ENOBs and ensure a moderate handover area. Okay? Note, increasing coverage may lead to co-channel and adjacent channel interference. Listen to me. Increasing coverage may lead to co-channel and adjacent channel interference. For this reason, your job is important. You don't earn $500 or euros per day to don't do nothing or just put the results in the computer or just analyze the log. You need to analyze the whole behavior network, because one change that you do, you can make a big mess on the network. You can leave a lot of people without the network sometimes. I remember on a case in Ireland, when I've been in 2009, of that people started some lockdown on the network because he don't know about how to, to follow the good behavior, and put in the fucking lockdown on the network, complete network in the hub site. So it was a big nightmare, but it's okay, man. It happens in the project so far. So there are a lot of people that working, must be very prudent, with your analysis, okay? You must be 100% sure that your study case will work on network, because there are SLA. If you don't agree with your SLA, you don't receive money. You're the worst. You broke your client. You broke your career as well. Okay. Continuing the resolving weak coverage problems, you must use RRUs, indoor distribution systems, leak feeders, and directional antennas to resolve the problem with blind spots in elevator shafts, tunnels, underground garages or basements and high buildings. Okay, are used indoor distribution scenes. I'm talking about the phantom cells as well. Analyze the impact of the scenarios and terrains on coverage. For example, let's talk about the one study case, okay? Searching for a weak coverage area by using a scanner or performing drive tests and UVs interface for user interface. Perform drive tests in a zero load environments to obtain the distribution of signals on a test routes. Then find a weak coverage area based on distribution. And then I have the picture here. When I have a properly timing and a good timing, I will put this picture to analyze on the video, okay, in the next video. But just to show, you have a weak coverage area with a track with a lot of red points. These red points consists in a minus of 115 on the, for example, RSERP for one the best cell and seal for LTUE. Okay, on the best coverage is the green one, that's 70 to 0, right? The level of the colors, okay. All right, so minus 90 to minus 80 is a good performance on the network, okay. And then you assign the best channel, okay, for the which sites. The weak coverage, where there's a most green, the most red one, okay, the most red one, minus 150 to minus 110, okay, then it's decreasing, okay. So okay, that's fine. This is the case. I hope that you understand it, guys. But if you have any doubts about this, please feel comfortable to ask me. I will talk about another study cases, okay, and so on. So it's very important to you understand the whole concept to performance networks, okay. When you make a scanner performance drive test, okay, and analyzes that's going to be structured for the network, okay. You can make it's for mapinfo. You can use mapinfo as well. Make the conversion mapinfo. I prefer to use a gladiator tool that you can check the whole plot on the network. But I have a lot of tools that you can convert these and check the strats on network just to see, okay, what happened, okay. For example, when you have a lack of dominant cell in the area without dominant cell, the received level of the serving, it's very important to be checked as well. All right, so I will talk about next video about this, but when you get these plots, you check the whole performance. You must pay attention on the levels that must be shown, and then you can suggest the changes on the network, physical changes and the logical changes. Okay, my friends, thank you so much. Cheers. Bye.